Hey there, AP Environmental Science class. All right, welcome back to part 2 on my lecture on chapter 17, which is talking about water pollution. So we're going to move on now, and we're going to talk about what are the major problems of groundwater pollution, okay? Chemicals used in agricultural, industry, transportation, and homes spill and leak into groundwater. So again, what are we talking about groundwater? Obviously, we're talking about water that is located under the ground, okay? Potentially in those aquifers that we spoke about in a previous unit, which are basically big reservoirs of water under the ground that people use for drinking and for agriculture and things like that. So, what are we talking about here? We're talking about what are major groundwater pollution problems. And again, chemicals in agricultural, industry, transportation, and homes spill, leak into the groundwater. Protecting groundwater through pollution prevention. Again, we spoke about this in the previous part 1. Obviously, it's least expensive and more effective strategy to protect your groundwater through pollution prevention than cleanup. I'll tell you right now, it is very difficult to clean up groundwater that has been polluted because it's located under the ground. So it's hard to get to that water to begin with, all right? And then if you end up polluting that water, well, it's very difficult to clean that water up, okay? So it's really important, especially when we're talking about groundwater, that you want to prevent pollution through pollution prevention when it comes to groundwater. You don't want to deal with cleaning up groundwater. So again, as I've kind of was alluding to, groundwater cannot cleanse itself very well. So what are aquifers? Again, drinking water source for about half of the U.S. population. Again, those are big reservoirs of water underneath the ground. Common pollutants, fertilizers and pesticides, gasoline, organic solvents, and fracking, which we talked about, put some chemicals into to be able to into the water that ends up fracking the shale. All right, that some of those chemicals obviously seep into the groundwater because fracking is actually occurring under the ground. Slower chemical reactions in groundwater due to slow flow contaminants not diluted, okay? Less dissolved oxygen you have under the water. You have fewer decomposing bacteria to deal with the pollutants. Again, what did we talk about in the previous part here? How those bacteria get come in and decompose a lot of the pollutants that maybe come into rivers, come into lakes. Well, underground, you don't have a lot of this bacteria. So you have less of it, which means the pollutants are decomposed of much more slowly. In addition, you have colder temperatures, which also produce slower chemical reactions. So it's these reasons why groundwater has a very hard time cleansing itself. And so once you get it polluted, the groundwater, very hard to clean up. And unfortunately, we are polluting a lot of our groundwater. This just kind of showing just how we pollute it. So here we got just understand a few of these. All right, coal strip mine runoff obviously gets into the groundwater. Okay, you have accidental spills getting into the groundwater, all right? Landfill, we'll talk about waste in a chapter coming up, but if you don't line your landfill good enough here, obviously water can seep out of the landfill, and that obviously will pollute your groundwater. Sewers, right? Buried gasoline or solvent tanks that may happen to rupture, okay, can pollute your groundwater. Pesticides and fertilizers, okay? A gasoline station, right, can have some of that gasoline link into the groundwater. And obviously polluted air. If you have acid rain that's falling down, that rain has some toxicity to it. Well, that rain then seeps into the ground, and obviously you have some polluted groundwater. So again, many ways that we pollute our groundwater, and unfortunately, the groundwater has a hard time cleaning itself. Groundwater pollution is called a hidden threat because, again, we can't see it. All right, it's not like the Cayuga River in Ohio that was on fire in the 1960s, right? We can't see the polluted groundwater, so it's kind of hidden from us. 90% in China of their shallow groundwater is polluted. About 37% so polluted that it cannot be treated for use as drinking water. So you can't even treat it, it's so polluted. Liquid hazardous waste are injected into the ground in disposal wells here in the United States. Again, some we looked at in that picture just before. EPA cleaning up leaking underground storage tanks. So again, you have some of these storage tanks that leak. Slowly degradable waste can take decades to thousands of years to clear underground. Non-biodegradable waste remain there permanently, like plastics. Prevention, again, is the most effective solution. You see it once, you see it twice, you see it 100 times. Prevention is the most effective solution in all of environmental science. It is cheaper to prevent than to clean up, but especially when we're talking about groundwater pollution, because of those reasons we stated before, groundwater, very difficult to clean up. So here are some solutions for you. Again, we love these charts, okay? So just kind of understand some of the prevention, some of the cleanup, all right? So prevention, find substitutes for toxic chemicals, keep toxic chemicals out of the environment, require leak detectors on underground tanks, ban hazardous waste disposal in landfills and injection wells, storm harmful liquids in above ground tanks with leak detection and collection systems. Cleanup, pump to the surface and clean and then return to the aquifer, but that is very expensive. Inject microorganisms to clean up the contamination. Less expensive, but still costly. This would mean inject bacteria into the groundwater to basically decompose it, but obviously it's costly. Pump nanoparticles of inorganic compounds to remove the pollutants. That's an area that is still being developed. So when it comes to groundwater cleanup, this could be an area that you, if you're getting into environmental science in the future, may want to get into, because we really don't have effective, cheap ways to do it. And obviously, groundwater pollution is a big issue, not only here in the U.S., but especially around the world in some of our underdeveloped nations. So if you could come up with a cheap way to clean groundwater, you might become a very rich man or woman. All right, so maybe this is something that you might want to look into as you head on off into the real world, quote unquote. There's a case study in here about arsenic in drinking water. Arsenic-rich rocks can contaminate wells. Arsenic produces long-term exposure that could cause skin, lung, and bladder cancer. Levels especially high in Bangladesh, China, India's state of West Bengal, and parts of northern Chile. Treatment approach, rust nanoparticles removed with a magnet, believe it or not, can kind of get some of this arsenic out of drinking water. So purifying drinking water, all right, we need to do that with reservoirs and purification plants. Process sewer water into drinking water by treating it, all right? So again, the water with human waste in it, if it's treated properly, can be turned into drinking water. And again, a lot of that is done here in the U.S., not so much done in other nations. Expose clear plastic containers to intense sunlight to kill infectious microbes that may be on the plastic containers, and the life straw filters viruses and parasites. Use that life straw to maybe filter viruses and parasites out of the drinking water. So another case study, is bottled water a good option? Bottled water can be useful, but it is expensive. The United States has some of the cleanest drinking water in the world. So the fact that we are using bottled water here in the U.S., maybe we shouldn't be as much as we are, because again, our water is rather clean. Bottled water does take huge energy inputs and does create environmental problems, obviously because of the plastic. 67 million plastic water bottles discarded daily in the United States, and unfortunately most end up in landfills. And as you know, plastic does not really degrade rapidly. It takes very, very, very long time to do so, and also to make the plastics, as we talked about in previous units, it takes a huge energy input. So the water itself is a good option. The problem is we're housing it in these plastic bottles that end up in landfills, and that is not a good thing. So you'll notice here in Ardsley, it's the reason why we have those, now the only things that are working in the water fountains, right, where you can put a water bottle underneath, because, and if you look, there's actually a counter. I'm sure most of you have seen it on top of it, showing you how many bottles of water you're actually saving, okay? And so it's very important to use a water bottle. Really, bring in your own water bottles and just fill them up there. Don't use those plastic bottles. Or if you do use a plastic water bottle, well, refill that water bottle a couple of times. Don't just use it once and then throw it out. Maybe refill it a few times with the water fountains here at the high school, and use it maybe 5 or 6 times and then throw it out. The point is we have all these plastic water bottles discarded all around. And again, most are ending up in landfills where they're not being degraded. And so you have this plastic lying around for a very, very long time. So we do have to talk about some laws that we use to protect drinking water quality. You definitely need to have some ideas of these laws, especially for the test coming up in May. 1975, we had the U.S. Safe Drinking Water Act, which sets a maximum contaminant levels for any pollutants that affect human health. Health scientists recommend strengthening the law. Various industries have lobbied to weaken the law, so you understand how that goes. Left developed countries, laws do not exist or are not enforced. So that's why we're having some issues with the drinking water in the less developed countries. And while here in the U.S. and in Europe, we don't really worry so much about our drinking water. We know it's safe. Other countries, obviously, a different story. The lead in Flint, Michigan. Maybe many of you have heard of this tale. 2014. It's actually still going on now. I think there's some litigation going on in Michigan because of this crisis. But in 2014, residents of Flint, Michigan were exposed to dangerous levels of lead in their tap water. Officials began withdrawing water from the Flint River instead of Lake Huron, but they failed to add chemicals to reduce leaching from lead pipes. So you have all these pipes that hadn't been used, all right? They started withdrawing water from the river instead of the lake, okay, through these pipes. Well, guess what? These pipes were so old that the lead was leaching into the water, and they didn't realize it, so they didn't put chemicals in the water to reduce that. And as a result, you had all this lead showing up in people's waters, and people were getting sick and were dying. We're getting a lot of the children being born were having birth defects, all right? And they traced it right back to this lead that was being leached from the pipes. Obviously, there was a public outcry, and it resulted in the water source being switched back to Lake Huron, which didn't go through these pipes. And again, still here we are now 7 years later, and it's still in the news as there's us trying now to make people accountable for this huge mistake that ended up harming lots of people in Flint, Michigan in the past decade. So again, just an issue. Again, we normally don't have to worry about our drinking water here in the U.S., but obviously that is not always the case. And this case study from Flint, Michigan from 2014 shows us that. All right, so now we're going to move on to the oceans. So remember, in the first part of this lecture, we spoke about river and lake pollution. And we just finished talking about groundwater pollution, and now we're going to talk about ocean pollution. So what are the major ocean pollution problems? Most ocean pollution originates on land, okay? So it's not like most of the ocean pollution is because of boats in the ocean, dumping waste and things like that. No, most of it, of the pollution originates on land, either oil and other toxic chemicals that end up in the ocean, solid waste, which ends up in the ocean, like plastics and things like that. And obviously, these things are a threat to the fish and wildlife, disrupting our marine ecosystems. What's the key to protecting the oceans? Reduce pollution flow from land and air and from streams that are emptying into ocean waters. So we have to deal with the pollution on land first, all right, and then that will help protect our ocean. So what's nice is that the stuff we talked about in the previous part of this lesson, the groundwater, the lakes, the rivers, that pollution prevention all goes into helping prevent pollution in the oceans. Because again, most of the pollution in the oceans originates on land somewhere where all us human beings are living. So ocean pollution is a growing problem. Municipal sewage from less developed countries often dumped into the ocean without treatment. This overwhelms the coastal water's ability to degrade waste. Again, in the olden days, when we just had, not as many people on the planet, there was no problem discharging human waste into the ocean because the ocean itself, the ecological services, the bacteria, things like that, would degrade the waste. The problem is now we have so many people, especially in these underdeveloped nations living in high density housing, and they're just sending all that sewage right out into the oceans without treating it, okay? And so what happens is you then overwhelm the ocean's ability to provide the ecological service of degrading that waste. In deeper ocean waters, you do get the dilution, you do get dispersion, and you do get some degradation. So it's a little less in the deeper ocean. All right, most of the ocean pollution that we have is really in the coastal areas. Okay, because in the deeper waters, while you do have some degradation, again, there's more dilution, there's more water there, and there's more dispersion of the pollutants around. In the U.S. coastal waters, okay, a little different. You have raw sewage, which could produce viruses. You have sewage and agricultural runoff, okay, your nitrates and your phosphates that can that obviously pollute, cause some of those dead zones, right? We spoke about off the coast of Mississippi River. You get those harmful algae blooms, right? Okay, that's the eutrophication, and you get then your oxygen depleted zones, your dead zones. Okay, so this is what's happening in the coastal waters. And again, just another chart that kind of shows you, what's going on out here. So again, industry, nitric oxides from autos, smokestacks, again, go into water, go into the air, that go into the ocean. Cities, toxic metals, oil, things like that. Bacteria and viruses from sewers and septic tanks, from urban sprawl, construction sites obviously getting washed in, farms, pesticides, manure, things like that getting into the ocean, okay? Red tides, excess nitrogen causes explosive growth of a toxic microscopic algae, which poisons fish and marine mammals. A couple of years ago, I was down in Florida in the summer during a red tide. It was kind of weird. You just sat on the beach and coughed. That's all you did on the beach, because these toxins would be released whenever the waves crashed from this bacteria, and the toxins would go into your lungs, and basically you couldn't go to the beach because all you did was cough. It was really a difficult 15 days, especially staying at my parents' house and with no beach to go to. Me and my kids had to hang out with my parents for 15 days. You can only imagine how that is, right? You guys can imagine. So obviously it does happen, and you may have heard about this a couple of years ago down in Florida. They did have that. They did have a red tide. Again, red tide is not red. Okay, it's just it's microscopic. It's toxic algae that releases toxins into the water, into the air, that kill fish and that make humans cough. Okay, so once again, just kind of understand what's going on here. Okay, your oxygen depleted zones, those are your dead zones. Toxic sediments can hurt the sand and things like that. And then obviously out in the deeper ocean, you do have more of a healthy zone. Okay, so again, just kind of understand some ways that the ocean is being polluted. All right, so I'm sure many of you have heard about this in the news. These ocean garbage patches that they're not going away. Okay, you may have seen these pictures of these big patches of debris that are basically floating in parts of the oceans. So the North Pacific garbage patch, 2 rotating gyres of basically garbage. Particles float on or just beneath the water surface, and 80% of the trash in these garbage patches come from land. So again, they're not, most of it not coming from boats or things at sea, they're coming from land. And there are these particles, tiny plastic pieces that are harmful to wildlife, hazardous chemicals that can move up through the food chain, right? As an animal maybe eats this, a little piece of plastic, it's toxic, and now they have that toxicity in their body that then gets biomagnified as we move up the food chain. And unfortunately, there's no practical way to clean it up. The best approach is just to prevent the growth by reducing the production of solid waste on land, okay? We got to reduce the production of this waste, or at least try to not get it into the ocean, because there's really no practical way to clean this up. And this is what we're talking about, all right? The North Pacific garbage patch, actually 2 slowly spiraling masses of small plastics that are located just north of Hawaii here in the Pacific Ocean. It is incredible. And again, I don't have any pictures for you right here in this lecture, but if you just look online, North Pacific garbage patch, you will see pictures of it. It's not really fun to look at. It's pretty disgusting. Okay, and there's actually 5 others of other of these have been found in the other world's oceans. So there are actually these garbage patches that sit there and spin around, and basically they're like eddies. They're kind of like gyres. They just sit there. Other garbage comes in, gets kind of caught in, and then you get these big patches of plastics plastics and garbage in the deep ocean here. And again, there's no real practical way to clean this up at this point. So again, maybe something else you can go into, figuring out how to clean this up. I'm sure you can make some money if you can figure out a cheap way to clean up these garbage patches that are floating around the world's oceans. Oil is also another ocean pollutant out there, and mainly it's because we pull oil out from underneath the ground, and many of our oil platforms and things like that actually occur or actually are in the water somewhere. So crude and refined petroleum from natural sources and human activities, urban and industrial runoff from land, okay, that's the largest source of ocean oil pollution from human activities. It's actually not those things in the ocean, the boats that carry oil or some of these platforms. It's actually just urban and industrial runoff, okay, just kind of stuff that we're using here in our activities, the oil running off into streams, into rivers that eventually make it into the ocean. But there have been some prominent pollution accidents. 1989, the Exxon Valdez. Sure, many of you, I'm sure you've heard of it, but for me, I was 14 years old, all right, when that happened. So I remember that. I remember that vividly. And just about 10 years ago, the British Petroleum Deepwater Horizon accident in the Gulf of Mexico dumped a lot of oil into the Gulf of Mexico there as well. Volatile organic hydrocarbons kill many aquatic organisms. That's what's in the gasoline. That's what's in the oil. All right, it's volatile organic hydrocarbons, and that pretty much kills many of the aquatic organisms when it gets spilled into the ocean. Tar-like globs on the ocean surface, all right, also coat animals' fur and feathers, and animals drown or die from the loss of body heat. I'm sure you've seen pictures of little ducks and little geese and things like that, birds with the oil all over them. Okay, obviously a big issue there. Heavy oil components tend to sink to the ground, so then you have smothered bottom-dwelling organisms. So again, it's the entire ocean that gets affected. Animals that live on the top of on the ocean surface get coated with these tar-like globs. Bottom dwellers that live at the bottom of the ocean get smothered as the heavy oil components sink down. You do get faster recovery in warmer water with rapid currents. Obviously, the currents churn it up, mix it up, dilute it a little bit, and the warmer water also has more microorganisms that will work on the oil. But in cold, calm water, the recovery can take decades. That was what was so bad about the Exxon Valdez. That happened up in Alaska, off the coast of Alaska. The Deepwater Horizon was in the Gulf where it's rather warm, but the Exxon Valdez happened up near Alaska, so it could take decades to recover. Current cleanup methods recover up to only 15% of the oil from a major spill. The other oil you can't recover. It either sinks into the ground or does other things, goes to the bottom of the ocean. Methods of preventing oil spills, double hull tankers are important. All right, you've got two holes in the tank. Obviously, that would prevent oil from spilling. Here is a picture of the Deepwater Horizon. All right, this was again an oil platform about 40 miles off the coast of Louisiana. This is April 20th, 2010. It caught on fire, basically exploded, caught on fire, and then sank. All right, and you can imagine that you have this well coming up with all this oil. Well, basically now it collapsed, and so now all the oil continues to come out, and it just pours out into the ocean, or into this case, the Gulf of Mexico. And this was a major incident back in 2010, and it did take a couple of years to clean up. Unfortunately, again, luckily the Gulf is a little warmer. They do have some currents there that helped. But this was a major ecological disaster that, again, happened just about 11 years ago now. Right, so this case study talks a little bit more about it. The spill from a deep sea oil drilling, it released 3.1 million barrels of crude oil before the well was finally capped and the oil stopped coming out of the ground, contaminated vast areas of the coastline, even though it was 40 miles offshore, caused by equipment failure and poor decisions by the folks that were running it. And since then, the government has developed new standards for offshore drilling procedures that hopefully will prevent a Deepwater Horizon accident from occurring in the future. So how can we deal with water pollution? Well, obviously, we want to reduce our water pollution. So the key is to prevent it, work with nature to treat sewage, and use our natural resources more efficiently. So Number one, how do we reduce that ocean water pollution? Reduce flow of pollution from land. We spoke about that, all right? Land use, air pollution, linked to energy and climate policy, okay? We want to reduce the pollution on land, and that will reduce the pollution in our oceans, all right? So again, our favorite chart here, some prevention, some cleanup from coastal water pollution, preventions, separate sewage and stormwater lines, all right? In many parts of the world, parts of the country, sewage and stormwater lines are the same, so separate them. Ban dumping of waste and sewage by ships in coastal waters. Require secondary treatment of coastal sewage. Strictly regulate coastal development, oil drilling, oil shipping. Use wetlands and other natural methods to treat sewage. Again, wetlands are an ecological system, ecological service, naturally filters water, and require those double hull tanks for oil tankers. Cleanup, improve oil spill cleanup capabilities, and use nanoparticles on sewage and oil spills to dissolve the oil or sewage still under development. Again, nanoparticles, that could be an area of study for you as you head off into college. Reducing water pollution from non-point sources, okay? So now we're talking about how to reduce our water pollution. So we spoke about the ocean. Now we kind of backtrack a little bit and talk about those non-point sources. Remember, the non-point sources were like your backyard, were like golf courses, were like farms, where all that fertilizer, those pesticides flow into the rivers and the lakes. We don't exactly know where they're coming from, okay? So methods to reduce the pollution, use soil conservation methods, right? Like we talked about in a previous chapter, to reduce that soil erosion, because again, not only are pesticides and fertilizers considered pollution, but just sediment itself, right, is considered water pollution. So use those soil conservation methods to reduce that erosion, to reduce that sediment runoff. Use fertilizers that release nutrients slowly. And don't use them on steeply sloped land, because if you have fertilizers on steeply sloped land, better chance that fertilizer is going to run off in a rainstorm, okay? And also use it that releases nutrients slowly. Produce the use and runoff of plant nutrients and pesticides. So you just have to try to reduce it, reduce the use and the runoff. Plant buffer zones of vegetation, all right, that can help reduce that runoff. And set discharge standards for nitrate chemicals from sewage treatment and industrial plants. So, reducing water pollution in the United States. All right, here are just some more of these laws. 1972, 1977 was the Clean Water Act. 1972, the Marine Protection, Research, and Sanctuaries Act. 1975, updated in 1996, the Clean Drinking Water Act. 1976, you had the Toxic Substances Control Act. 1980, all right, known as CERCLA, the Comprehensive Environmental Response, Compensation, and Liability Act. 1987, Water Quality Act. 1990, the Oil Pollution Act. All right, experimenting with a discharge trading policy that uses market forces. And of course, what are some of the achievements of the Clean Water Act? Talked about this in the case study. Obviously, some of the achievements was producing clean water for most of us here in the United States. So my advice is to just know some of these laws, just kind of have a general understanding of what they do, what they talk about. So if you ever need to use them on an FRQ, you have a general knowledge of some of these laws that help reduce the water pollution here in the United States. We now move on, all right, to sewage treatment. Just a couple of slides left, all right. Sewage treatment reduces water pollution. So we do have septic tanks that are used in rural areas. Wastewater or sewage treatment plants are used in the more suburban and the urban areas. We have primary sewage treatment, which is a physical process. And then we have secondary sewage treatment, which is a biological process using bacteria. Some sewage treatment plants also have a tertiary or an advanced sewage treatment, and that's special filtering processes along with bleaching and disinfection that helps take sewage and basically clean it up, all right? So many cities violate federal standards for sewage treatment plants. Federal law requires at least primary and secondary treatment but there are some exemptions from the secondary treatment. Health risks result in swimming from water with blended sewage wastes, and obviously that's because of the microorganisms, the viruses, the bacteria that are in sewage that obviously provide a health risk when you swim in it. So here's a septic tank. All right, I'm sure most of you here in Ardsley don't have these, but actually where I grew up in Ringwood, New Jersey, which is just about 25 minutes from here, my parents still have a septic tank. They don't have a municipal sewage system in Ringwood, or at least in parts of Ringwood. So basically what they have in their backyard is they have a drain field with gravel or crushed stone. Basically, all right, the sewage comes out of your house, all right, gets caught up in this kind of this septic tank here, all right, which is basically what we're looking at here, all right. You got gas on the top, all right, the gas gets separated, the methane. You then have your scum, you have some wastewater, and you have some sludge that kind of sinks to the bottom. The wastewater then goes out into this field where it basically sinks through this gravel or crushed stone, which provides the ecological service of actually cleaning up that water. So most of your the hard stuff from the sewage kind of falls into the sewage tank as sludge and as some scum, but then you have the wastewater that goes into the field here, and then again kind of perforates through the pipe into this gravel or crushed stone, the drain field, that then as the water slowly sinks into the ground, it purifies that water, and so you don't have any issues with sewage seeping into the ground when you talk about a septic system. Here is your sewage system. This is, again, sort of what we have here in Ardsley. This is what would come from a sewage plant, a plant that treats sewage. And again, here's your primary and your secondary. So here comes the raw sewage from the sewers, all right, into this bar screen, which obviously will filter out a lot of the heavy kind of sewage, which will stay here. Then you have your grit chamber, which again, with gravity, kind of gets out more of the grit. Then you have the settling tank, right, where the sludge ends up being here. The sludge goes into this sludge digester and then into a sludge drying bed. And then this can be disposed of in a landfill or the ocean, or maybe even applied to cropland pasture or range pasture. This is actually some good fertilizer that you can use. What's the secondary? Well, the secondary, okay, part of the sewage plant is then you have this water that continues to go into here, and you have an aeration tank, all right, which actually aerates the water. All right, putting air in it, which helps clean it up. Then you get into the settling tank, which settles more of that sludge. Oh, sorry. All right, that may be left over. Again, not as much as you see here, but there still will be some sludge left over that sinks to the bottom and then goes into this sludge drying bed, which then you can be used or just disposed of. Okay. Then you have, all right, there's also bacteria in here in this aeration and this settling tank, which is working on the sewage, okay, trying to again degrade or get rid of it, okay. It's basically eating it in a way, all right, the sewage. Then you go into this chlorine tank, which kills the bacteria because you don't want that bacteria out in the world, okay, because the bacteria is just being used to eat the waste, all right, to process it. And so then this kills the bacteria, and then you outsource this water, or you discharge it back into the river, lake, or ocean. And that's okay, because at this point, the wastewater has been totally cleaned by a primary and a secondary sewage treatment plant, all right? Again, it's primary. Get this raw sewage that kind of just gets filtered out, settles into this tank, dried out, can be used. Then the rest of the water goes into these aeration and these settling tanks where, again, bacteria working on it, okay, microorganisms, all right, to disintegrate the waste. Then you get the water to go into here. Chlorine kills the bacteria, and then you have pretty pure water that can go back into your rivers, your lakes, or your oceans, all right? So this is the way sewage treatment needs to be done. And again, what's happening? Well, in many areas, you may not have this secondary, so you're just getting the primary, which works, but doesn't work as well. And in many of our underdeveloped nations, you're bypassing all of this, and the raw sewage from the sewers here just goes right out into the lakes or the rivers or the oceans, all right? And you're bypassing all of this, All right. So again, this is what's needed, at least your primary and secondary. And then again, some sewage treatment plants, if they're really great, will even have a tertiary part to this where you clean up that sewer water and basically produce water that is perfectly clean that then can be discharged back into rivers, lakes, or oceans with no issues, with no pollution involved. All right, so what we want to do is we want to improve our conventional sewage treatment, remove toxic waste before the water goes to the municipal sewage treatment plants if possible, reduce or eliminate use and waste of toxic chemicals in this process, use composting toilet systems, all right? So what is composting toilet systems? That's to just let bacteria kind of deal with your waste naturally, very similar to a compost out in your backyard where you put your leaves and your grass that then turn into soil. Well, there are some toilet systems that actually works as well. All right. And wetland-based sewage treatment systems work with nature. They're actually, in some parts of the world, they're trying to actually use wetlands instead of that filter system that I showed you with the rocks and stuff in a septic tank. Use wetlands to naturally filter out the sewage treatment. It's cheaper than having, let's say, those primary and those secondary sewage treatment plants work with nature to use the ecological services that nature provides us to clean out these to clean out water pollution. And it is cheaper. And so it has been, they're trying to develop these for some underdeveloped nations to use the wetlands to actually as the base of your sewage treatment system. So again, this is kind of in the working right now. This is another area of environmental science that is kind of just beginning to form. So maybe this is a little niche that you can get into if you are going to pursue a career in environmental science. All right, some sustainable, last but not least, sustainable ways to reduce and prevent water pollution. So obviously in developed countries, bottom-up political pressure to pass laws, all right, like what happened out in the Cayuga River in the 70s in Ohio. People were seeing their river on fire, realizing that wasn't good, and so from the bottom up pressured politicians to pass that Clean Water Act. In less developed countries, little has been done to reduce water pollution. All right, so we need to get in there to help these folks. China has plans for small sewage treatment plants, but again, they're having a hard time getting up and running. And again, how can we avoid producing water pollutants in the first place? All right, that's just preventing pollution on land that can help us in water. So some solutions here: prevent groundwater contamination, reduce that non-point runoff. Again, the point runoff we can deal with. We know where it is. Non-point runoff, we have no idea. All right, so try to reduce it. Work with nature to treat sewage and reuse treated wastewater. Find substitutes for your toxic pollutants. Practice the 4 R's of resource use. Again, a lot of this stuff is the same. Refuse, reduce, reuse, or recycle. Reduce our air pollution, reduce poverty, and slow population growth, all right, can all be solutions to help with water pollution. All right, our final slide here. What can you do? All right, to reduce water pollution? Well, fertilize your garden and yards plants with manure or compost instead of commercial inorganic fertilizer. Minimize your use of pesticides, especially if you live near a body of water. Prevent yard waste from entering storm drains. Do not use water fresheners in toilets. Do not flush unwanted medicines down toilets. Do not pour pesticides, paint, solvents, oil, antifreeze, or other harmful chemicals down the drain or into the ground. All right, so that concludes my lesson on Chapter 17, Water Pollution. And as always, thanks for listening.